What's number 1? C. Now, what's the other name we could give that? Who remembers from the 10th grade, which should be 98% of you? It would also be Lil W. Because it's a cross or opposite from Big W. Angles get capitals. Sides get lowercase. Name the side opposite angle WXY. What is it? What's the answer? A. Wait. No. WXY, WY, B. B. Name the side adjacent to angle P. What letter is it? C. Because adjacent means touching, but not the hypotenuse. Number 4. What is it? E. I would expect on that page, you all, for me to go on fearlessly, I would expect 3 out of 4 there. Cos theta. What is it? C.
I almost got that one wrong. Because I didn't do it right. I did sign.
Number 6.
Why did you choose this over
Anyone? D. How did you know this was 12? No, because of Pythagoras. 169 minus 25 is 144. The square root of 144 is 12. That is not why you know it is 12 over. Oh, it's the only other option. No. Pythagoras. Number 7. It is A, because it is angle X.
Oh, yeah.
I am a little bit nervous now.
I don't really know how I got the answer, but I got
Number 8. What could I use to find the hypotenuse? What is it, Harkirat? E. Cos 20.
I didn't know what to decide this
On that page, you really should have been rocking 5 out of 5. Oh, 4 out of 4. Yeah, you should be doing 5 out of 4 on that, people. I expect at least 125%. 148. Oh, by the way, what should you be doing if you get the wrong answer?
Circling the right one.
Thank you, Harkirat. You should ask. Circling the right one doesn't help you. Number 9. It's A?
I'm pretty sure.
I don't
hope
think so.
I hope it's A. Because if it's not, then I'm going to feel pretty dumb. That's also, if it's not A, it's not.
No, it is A.
Oh, yeah. I'm right. Use second.
Second cos bracket 0.906 equals. Or, if you have a backwards calculator, 0.906 second cos. Which of the following is correct? E? I have heard someone say E. E is correct. Anybody need it explained? Okay. 25 is the angle we have. 7 is opposite. M is adjacent. Tan equals opposite over adjacent. Opposite is 7. Adjacent is M, but it's also NP. It is easy. Find the measure of angle A to the nearest degree. What must you use? Sine, cos, or tan? Cos. And it is? It is? What is it? Nobody got this one? It's B. Because that is shift cos, which of course is this, of 15 divided by 17. Adjacent over hypotenuse. What is 12? C. Anybody need to see that in? What? Okay. Tan 25 equals 7 over M, because M is NP, right? Do algebra. How do I get M isolated? You would multiply both sides by M, cancel, cancel. Now I have M tan 25 equals 7. Now what do I got to do with tan 25? Divide by, not 7, I want M isolated.
Oh, divide by
Tan 25, cancel, cancel. Now I have M equals 7, which was already there, over tan 25. And the shortcut, you of course remember, is they just switch places. And number 13. What is it? I hear a B. I hear a D. It is D. Do we know why? It's not Y, Mr. Myers, it's D. What am I going to use? C. If this is 45, what is this automatically? Also 45. if little b is 15, okay, how am I going to find c? There's two ways to find it. You could use sine, or cos, or Pythagoras, yes? Because what do you know about A and C? If that's 45 and that's 45, what do you automatically know about A and C? They're the same. So 15 squared must equal, A and C are the same, yes? So 2c squared, right? So you can figure it out that way. And what is the answer? B. No, it's B, not A.
Oh.
Joke never gets tired. What?
I got it right.
So go.
You know, in my mind.
Now,
I said it out loud.
when I gave it to you Friday, people were nervous, trepidatious even. Now we have gone over it. People still nervous? Do I need to do a lesson on basic trigonometry? Or do you think that you will pick it back up from the little bit of background that I do every unit? Do I need to do a strict lesson on trig with how we name the sides and everything? Would that help you all? Yes? All right. Is it one you feel you need to write down, or do you think you could just watch it and let it wash over you? Watch it. All right. So, let us begin cabbages. I have purposefully labeled this triangle weirdly. There's a reason for it. What should this side's letter be? Small a, because it is across from big A. Why have I labeled it poorly? Because all of you are used to calling the hypotenuse C, which is dumb. I hate a squared, b squared, c squared. Because as soon as I say a, b, c squared, you all can't do Pythagoras, which is one of the easiest things to do in math, because you can't deal with the letters being in other order. So that is why I have done this. What is this? Little c. What is this? Little b. What is Pythagoras on this triangle? C squared plus b squared equals a squared. Don't do a squared, b squared, c squared for Pythagoras. Do leg squared plus leg squared gets you hypotenuse squared. That way, you'll never screw it up, no matter how the teacher messes with the letters. Which are the legs? Oops. Which are the legs? The ones that are not the hypotenuse. Where does the hypotenuse always live? Opposite the right angle. What does opposite mean? Opposite equals across. If you have to cross a shape, you are going to the opposite side. Okay? We all remember that? All right. Next thing. And you're going to see this all again in your notes, so you probably don't need to write it down. This symbol means what? Theta. It is a Greek letter designed to delineate the angle that we seek. It is not necessarily unknown. It's the angle with which we are working. If I am working with this angle, then there are 3 trig ratios that you need to know in the 11th grade that you already know from the 10th grade. There is sine, cosine, and tan. Sine is O over H. O stands for opposite, so I must go across. And what do I hit? C. Over hypotenuse A. Cos is A over H, which means I go beside B over A. And tan is O over A, which means it is C over B. Now, if I go to the other spot on the triangle, what changes? Opposite, adjacent, or hypotenuse? Or a combination, or all three? What changes? Say it proud, Kieran. Opposite and adjacent change. Why? Because I am on the other side and the hypotenuse has not moved at all. It is still across from the 90. So the sine of the red sine is B over A. The red cos is C over A. And the red tan is B over C. Please notice the relationship. Black theta's sine is red theta's cos. Black theta's cos is red theta's sine, and the tans are reciprocated. Does everybody remember trig? Great. Now you need to remember the algebra. Tan 25 is just a value. This is just a number. What instrument knows that number automatically? Your calculator. If that equals 7 over x, all that is the same math that would be this. 10 equals 20 over x. How would you solve that? You would isolate x. How would you solve that? You would isolate x. The only difference is this is now a decimal number that your calculator already knows. It's not 10. Okay? So you would do the exact same algebra you would do to solve this, but you can't do it without your calculator. All right? Everybody good now? Can we risk going forward? You all think you are ready to try? Remember, we're going to be doing these as actual examples. It should work out. Everyone is good? Let us begin then, cabbages. Let us begin. Turn to page, I assume, 150. Now, in grade 9, which is when most of you saw trig, or some of you saw trig, or grade 10 when all of you saw trig, you dealt with triangles that looked like this, yes? There was always a 90 degree somewhere in that triangle. How did you know where the 90 degree was? There was a little square there. Now, you're intelligent young people. You have all done trig in this quadrant of the Cartesian plane, yes? Always, no matter what. There was a 90, there's a theta. You had a value here, a value there, and you did trig. Now some of you will say, but Mr. Myers, sometimes it was rotated. like that. Right? But that would be the same as rotating this thing this way. Does everybody understand? Okay. Now, we now are going to discuss the entirety of the degrees available to us, which is what number? 360. But hopefully with your eyes you can see that each of these corners makes what? A 90 degree. So if you can do the trig over here, isn't it the same thing as in the other three spots? Yes. So what you already know is sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. We have already reviewed what opposite, adjacent, and hypotenuse mean, so we should be in good shape. Yes? So to here, we're okay. Now, we got to remind ourselves some stuff about this construction now. What is this line? The x-axis. Agreed? And any dot on that line has an x value, correct? All right, good. What is this line? I've just given it away by writing it. The y-axis. And what does every dot on that line have? A y value, yes? What is every one of these blue dots' x value? 0. What is every one of these red dots' y value? 0. Good. We can read the Cartesian plane. That makes me a happy man. Now, you guys should have all this instruction here, yes? We're going to talk about each of these. The blue is going to talk about this first line. I'm going to highlight the important words. You may want to underline them. Standard position. If its vertex is at the origin and its initial ray lies on the positive x-axis. So let's break that down a little. Standard position is what we seek. Vertex. Do we know what a vertex is? What is it, Noah?
It's the top and bottom of the parabola.
It is the top and the bottom of a parabola. I agree with you. So if I do a parabola like that, there is the vertex, yes? How do I know when I've hit the vertex? What happens? Down, 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 down. What happens right there?
Stops going down.
I stop going down and I turn around, yes? Okay. Let's make this an angle. I start down that path. What happens right there? I stop there and I turn up that path, yes? So what is a vertex? It's the turning point, right? So in a parabola, it's this, yes? What is it in an angle? The corner. So, an angle is in standard position if its vertex lies at the origin. Where is the origin? Right there. So if I ever have an angle that has its corner there, that's the first thing that's important. What's next? Its initial ray lies on the positive x-axis. Where is the x-axis? It's the horizontal one. Where is the positive side of it? On the right. So it would be here. So that satisfies all of this. Vertex at the origin, initial ray. What's a ray? Do we remember that? It's a line that starts from a single point. Because a line goes in two directions. A ray only goes in one. Everybody cool? Now, the next part of this will be a red line. The other ray, because how many rays do you need to make an angle? 2 that meet at a vertex. The other ray is called the terminal arm. So, I start here and I go up to a terminal arm. This angle, theta, is in standard position. Is everybody good? Okay. Now, in green, we will do this. Counterclockwise. Where do you think we start counting from? If the initial arm is on the x-axis, what does that mean? If I tell you the initial name on my class list is Jack Anderson, what does that mean? First. So the initial ray must be the first ray, yes? So I must start counting from the first ray, which is right here, yes? Counterclockwise means I have a positive angle. What direction from here is counterclockwise? Up or down? Up. So this would be a positive theta. What are the values that it could be? Anything between what and what? It can be 0 up to 90. Agreed? Everybody understand? So in quadrant 1, because this is quadrant 1, all my angles are 0 to 90, yes? Okay. What about quadrant 2? I start here, and I go all the way around to here. In quadrant 2, what must they be? 90 to 180. In quadrant 3, what must they be? 180 to what? 90, 90, 90. What's 90 times 3? What's 9 times 3? And then add a 0. 270. I was close. And if it is in quadrant 4, what is it? Those are all positive because they are counterclockwise. If they are clockwise, all of that is reversed. Okay? So this fourth quadrant line is positive 270 to 360, right? What would it be negative? Now I'm starting here and I'm going this way. So it's 0, but not negative 0, duh, to what? Negative 90. What would this one be? Negative 90 to negative 180. And this one is negative 180 to negative 270. And this one would be negative 270 back to 0. Is everybody good? If I go up from the x-axis, it's positive. If I go down, it's negative. Everybody okay? All right, let's practice. Where is 30 degrees? What quadrant? First quadrant. I'm asking you to get out a protractor? No, just draw the line. But I want to see an initial, a terminal, and the 30. Everybody cool? Everybody good? Yep. Okay, I'm going to make a change here and make F negative. Draw those 5. You may work with your neighbor. Go. Howdy doody, neighborino. Can I borrow your trigonometry? I expect 5 drawings that look like that one. 2 rays, an arrow, and a value. If you do not understand what I mean, I'll do this one. First ray starts here. 135 means it has to go past 90, and I went positive 135. Now you really should be able to figure out the other 4 by yourself.
That's not wrong. That's so wrong. Oh, I didn't do that. I messed up one.
What is going to be the same on all of them? They're all going to start on the initial x-axis, yes? Yep. On the positive x-axis. Now, is there anybody that's feeling confident? Jorrit, tell me what direction to go from here. Up or down? Up. Tell me when to stop. Absolutely correct. 245 degrees. Because to here is 180, and then he went a little bit past. Did he get to 270? No, so we're cool. Who else is feeling confident now that you've seen Jorrit? Isabel, I must start there. Tell me up or down. Tell me when to stop. Abso-smurfly correct. 65. Who else is feeling confident? I'm hurt that I am not fighting off questions. Zach. Jack. Up or down? Up. Tell me when to stop. Abso-smurfly correct, because he went past 270. Now, let's see who's really ready. Who's doing F? Isabel, up or down? Down. Tell me when to stop. Abso-smurfly correct. Does everybody understand how the circle works? Yep. Does everybody understand clockwise and counterclockwise? Yep. Unless you're in Britain when it's clockwise and anti-clockwise. And then to make a fun joke, I sometimes say uncle clockwise for regular clockwise, because anti-clockwise, uncle clockwise, get it? That's so bad. Shut up, that's funny. That's so bad. That's better. Everyone can do it? I think you're liars. Down at the bottom, give me negative 192 and give me positive, on the same graph, positive 168. Go.
What was the first one?
Negative 192 and positive 168, which I will do in pink.
Whoa, what the heck? Did you get off?
Hopefully you will all say, whoa! Why do you have to say whoa? Because they're the exact same thing. Negative 180 and then 12 more degrees. Or positive 12 less than 180 to get to the same spot. Is everybody good with the circle? Going once. Going twice. Look, I made a vertex. Is it in standard position? Why not? No line on the x-axis. Is it in standard position now?
Well, maybe to you, not to us.
That's not horizontal?
Well, it doesn't have to be on the positive side.
Oh, you sneaky. Go get a gummy bear. I never even thought of that. I should have gone like this. Now is it in standard position?
Wait, can I invest?
Please say yes, because this is hurting my elbow.
Yes.
Okay. You want to invest?
Yes,
You sneaky. Oh, I like that, Noah. Woo-hoo-hoo.
I was paying attention.
Okay. All right. Everybody cool? Now, the last thing we did, what did we discover? That this line was the same, yes? Okay. Given an angle in standard position, the reference angle is the angle between, and this messes kids up, between the terminal arm, and I'm going to highlight that, terminal arm, and the nearest. Now, please notice I have capitalized it. I have highlighted it. And I have put a Mrs. Bad Crumble cloud around it. How important is the word nearest to this sentence? Very. It is almost omniscient in this sentence, which is, of course, all-knowing. It is almost omnipotent, which is, of course, all-powerful. And it should be omnipresent, which means everywhere in this sentence, is how important that word is. The nearest x-axis. Now, what do I mean by that? We will do 4 examples. Count them 4. Somebody say a number between 0 and 90. 45, the boring one. I would like an angle in standard position drawn at 45 degrees. Boom, boom. Agreed? This is 45. So that is theta. What is theta's reference angle? $45 degrees. Why, Jack? This is the nearest x-axis, so this reference angle is 45. In quadrant 1, theta equals its reference angle. Everybody cool? All right. Now, somebody give me a number between 90 and 180. 140. Tell me when to stop. Where is theta? On the right or left? On the right. And how big is theta? 140. Where is the reference angle? Where's the terminal arm? This one or this one? The terminal arm. What does terminal mean? If somebody is terminally ill, what does it mean? They're going to die. They are approaching the end. When you get in a train, you get out at the terminal where your journey ends. So, which is the terminal arm? The horizontal or the diagonal? The diagonal, which means the reference angle is between the terminal arm and the nearest x-axis. Where is that? If you were to walk from this point to an x-axis, where would you walk? You would walk to the nearest x-axis. I'll say it slower. Where is the x-axis? The horizontal one. What's closer? There or all the way back to there? This one. What is my reference? 40. In quadrant 2, reference angles equal 180 minus theta. Because if I went all the way there, it was 180. But I didn't. I only went 140. So there's 40 left over there. Does everybody understand? Excellent. Now, let us give me a number between 180 and 270. What is it? 187. Tell me when to stop. Oops, those are that's my reference angle color. Tell me when to stop. That's not what I want. It'll do. No, it won't. Tell me when to stop for 187. What is the reference angle? Why are you saying -7? Because I have to reverse, right? Okay. Jorit says it's -7 because this is 180, yeah? Everybody agree? Okay. Reference angles, we don't bother with that. That's only when we're going from an initial arm. So if we don't bother with the negative, is the 7 right? Yes. Quadrant 3, what does our reference angle equal? If in quadrant 2 it's 180 minus theta, what is it in quadrant 3? Theta minus what? Theta minus 180. Theta was 187, but I'm taking out this 180. Everybody good? And lastly, give me a number between 270 and 360. 333. Tell me when to stop. 333 is theta. So where is the reference angle? Where's the reference angle? Same place it always is. Where's the reference? Right there. And in quadrant 4, what's the reference angle? How do you know how far that is? 360 minus theta. Is everybody good? Now, what's the one thing we have to remember that Jorit remind us of? Reference angles are positive. Okay? We don't bother with directions on the reference angle. It's just a value. Everybody cool? All right. Prove it. Draw 4 angles and reference angles. Go. Bathroom time. Okay, good luck. Boy, I hope you can handle it on your crutches, Rhea. I'm just kidding. Good luck. Although you don't need it, because I believe you've outscored your opponents 377 to nothing.
We were doing really good until our last game. We had no goals scored against us until we played Sardis.
I believe Sardis has 2 girls that are off to play for Canada, so you should. It's okay. Anybody want the magic pen? Come up and show me what you've got.
How was the first one just 15? I just copied it.
Yeah, imagine. What I taught you being the way to do it? That's crazy talk. Why would I teach you how to do something?
Yeah, I just copied it.
Where's 15? Right there.
Okay, the nearest
Right?
x is 0.
What's the nearest x-axis?
Is 0.
That's 15. Is it in the first quadrant?
Yes.
And in the first quadrant, reference angle is what to theta? In quadrant 1, theta equals reference. Why do you think I wrote it?
Because that's what it is.
So what's the reference angle here?
15.
15. In number 2,
Oh, I didn't get that.
120. Right? Where's the reference angle? Right or left of the terminal arm? Left. What is it? 180 minus, what's theta?
120.
So what's the reference? 60. 250. Where's the reference? Back that way. What is it?
180. 180 minus 250.
Other way around.
No, 250 minus 180.
250 minus 180, so it is
No, I can't do that, man. I'm not sure.
25 minus 18, man.
You got me stumped there. Can't do that. 7. I use my calculator that bad boy. 7. Is it 7? 7. Oh yeah, because it's like 15. 8 and 7 is 16. Yeah. That's why I use my calculator for everything.
What's the reference?
I can do that one next time.
You sure? You got that one?
Yeah.
Nailed that there, did you? Okay.
No, it's not confusing. I just couldn't do
Is everybody good?
Yeah.
Now, notice the very next thing I've done. Usually when dealing with the coordinate grid, we have what? Usually when dealing with the coordinate grid, we usually have what, Noah? Coordinates. Oh my goodness, what do we have here?
Coordinates.
Coordinates. Crazy talk. Where is 3, 2? What quadrant?
First order.
First quadrant. Out 3, up 2, yes? That makes an angle. Right? What is the maximum value that angle could have had? Maximum value would have been 90, right? But it's not 90. Okay. Where's this one? Quadrant 3. Everybody see how it works?
Yep.
Where's C? Oh, I'm using my reference angle color. I'm sorry, ladies and gentlemen. What an idiot. Where's this one? Quadrant 2. Quadrant 2? 2, negative 4. Quadrant 4. X's go first. Where's this one? Quadrant 2, negative 10, up 5. You do those 4. Is everybody good? No, I go right 4 and down 2 because 4 is the X's. Now, ladies and gentlemen, please notice we are mashing together 2 separate things. We are putting together coordinate grids and angles. Is everybody good? Yeah? Everybody's cool? Everybody could do A, B, C, D, E, F, G, H? What if I gave you I, J, K, L, M, N, O, P? What if I gave you Q, R, S, T, U, V, W, X, Y, and Z? You could do them all? Right. Because you just put the dot at the point, connect it to the origin, and that makes your angle. Can everybody do it? Great. There's your homework, page 152. Now listen to me and listen to me closely. What is happening tomorrow? On what? Rational expressions. You still have 20 minutes left in class. Option 1 is what? Prepare for that test. Option 2 is this homework. When will I ask to see that homework? Woden's Day, which is Wednesday. Now let us pretend, cabbages, that you do nothing tonight. And you finish. Well, let's not say we're pretending. Let's say what's really going to happen. What will you do tomorrow when you finish your test? Start working on what page? Page 152. For me to check it on what day? Woden's Day. Excellently done. Now, if you wish to do this all now, and because you are ready for your rational expressions test, and you finish your rational expressions test early tomorrow, are you allowed to go, want to talk? No, I'm doing my work. Are you sure? No, I'm trying to write my test. That little fiction never happens, right? Because you will talk to the person. Or this fiction. Hey, want to talk? I'm done. Here's the real fiction. Are you crazy? I haven't finished page 152 yet. I'm going to work on it now in class. Thank you. I'll be appearing here till the end of the week showing you my acting talents, because that was all quite obviously fiction. Right? Excellent.